In this lesson, we're going to be talking about topic 1.3, normal distributions, and this is in your textbook and your HMH Algebra 2 textbook at lesson 23.2. As always, we're going to make sure that you write your last name and your first name always on your page, and we're going to be answering the question, how do you find percents of data and probabilities of events associated with normal distributions? And so by the end of the lesson, you should be able to do, I can use a normal curve to examine data, and I can calculate and use a z-score to examine data. And remember, between the essential question and the summary, you need to have 2 comments or questions in the left-hand column. So we're going to split this probably into 2 videos. The first one, we're going to talk about the normal curve. And just so you have the context of the normal curve, sometimes college professors will use this to grade. So if you think about it and you have if you have the mean score of a test in college is a 50, and then say the standard deviation is 10, just to make it simple. So you'd have 60, and then 70, and then 40 this way, and 30 this way. And then, so everybody between the first standard deviation would get a C. Then everybody in the positive direction within 2 standard deviations would get a B. And then the other direction would get a D, and then 3 standard deviations would get an A or an F. So you can see that the majority of everybody would get a C, and that works great if the mean is 50%. But what happens now if we switch the mean to 80%? So now your C is actually at an 80%, which we would normally think is a B. So that's just to put it in little context of where it may affect you at some point. So so typically there's a set of numbers that we actually have to that they actually explain the normal curve. So all normal curves have the following properties, sometimes collectively called the 68, 60, 95, 99.7 rule. So 68% of the data fall within 1 standard deviation of the mean. So the mean is here. So within 1 standard deviation, so you add the standard deviation, you subtract the standard deviation in each direction. 68% of your scores or your data will fall there, which means if I cut that in half, that's only 34% on each side of that. 95% of your data is going to fall within 2 standard deviations of the mean. So what that calculates out to be, if I go within 2 standard deviations, our next little chunk is 13.5%. The numbers in this one over here are what you're going to end up using, okay, to calculate. And then within 3 standard deviations, we get 99.7%, meaning this next little chunk is 2.35%. And then the last one, notice that's 0.15%. So if I were actually going to write that in decimal, that would be 0.0015, okay? This one here would be 0.235 if I'm writing it in decimal, because we're going to flip back between decimals and percents. All right, so we're going to be given a problem that looks like this. Suppose the heights of men ages 20 to 29 years old in the United States are normally distributed. So as soon as I see these words normally distributed, I start thinking about this curve. Okay, so I automatically go and I draw my curve as soon as I see the words normally distributed. The mean is 63.9 inches, and I probably drew my curve a little bit too big. 69.3. Okay, so I draw that in the middle. That's my mean. Inches, and a standard deviation of 2.9 inches. Okay, so when I set up my normal curve, I know I've got to go 3 standard deviations in each direction, right? So 1, 2, 3. Okay. And then I'm going to keep adding and subtracting on both ways. So when I go this way, I'm going to add my standard deviation of 2.92. When I go this way, I'm going to subtract my standard deviation of 2.92. I made this way too big. Try that again. 2.92. All right, so when we're subtracting. So when I go up, I end up with 72.22, 75.14, and 78.06. And then going the other direction, when I subtract, I get 66.38, 63.46, and 60.54. And then I layer in these percentages that are the same every single time. So I know within 1 standard deviation each direction, I'm 34%. Within 2, I'm now putting a 13.5% in here. This is going to help us answer the questions. 2.35, and then 0.15%. All right, so now we're supposed to look. We haven't even looked at the question really. It says the percent, so we're keeping it in percent of men between 63.46. What do you know? 63.46 is right there. 75.14. So we're supposed to be finding the percent of men that are between these two values. So I need to take those 4 numbers and I need to add them up. We get to keep them in percentages, okay? So I'd take 13.5 plus 34 plus 34 plus 13.5, and I end up with 95%. All right, then the next question in B is asking us to find the percent of men that are taller than 72.22. So I'm going to find 72.22. It's right here. I need everybody taller. So I'm going to add up the numbers that are to the right. 13.5 plus 2.35 plus 0.15. And when I add those up, I would get 16%. All right. The next one, we're going to use the same data, okay? And if you want to pause and try to figure out the percentages yourself, you can. But we're going to do the percent of men who are between 60.54 and 78.06. So 60, I might erase some of my colors on here. Let's see if I can erase just a little bit of my coloring on there. Okay, oh, I got rid of my curve. Got to draw my curve back in. Okay, so I'm going to use a different color. It said 60.54. So 60.54 is here. And 78.06. 78.06 is here. So there are a couple of ways I could do this. I could just add these guys up, just like we were doing before, which is probably the most straightforward and easy way to do it. So 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35. And I end up with 99.7%. Another way for me to do this was I know that the overall percentage is 100% always. So I could have done 100% minus these 2 little percents at the end, the 0.15 and the 0.15 added together. So I could have done this. And I still would end up with the 99.7%. So your choice. The last one says the percent of men who are shorter than 64.54 inches. So 64.54 is here. I need the percentage, so it's going to be 0.15%. If they ask for probability instead of percent, okay? So let's say they ask for the probability of men who are between. So you take this and you would switch it to decimal points. Remember, you'd swap it to 2 decimal points to the left. And so that would be your probability. Your probability is always a number that's between 0 and 1.